In this lecture, we will discuss encoders, decoders, and attention mechanisms. Encoder-only transformers are designed to use self-attention to create context-aware embeddings. Essentially, self-attention helps the model understand the relationships between words in a sentence and cluster similar sentences together. For example, sentences like "pizza is great" and "pizza is awesome" would be grouped because they have similar meaning. Similarly, documents with related topics, such as music or recipes, can be clustered together. This makes encoder-only transformers useful for tasks such as text classification, where the model decides yes or no or assigns a label. Decoder-only transformers, on the other hand, use masked self-attention to generate output. While encoders focus on understanding the context, decoders are designed to produce sequences of text. In decoders, masked self-attention ensures that each word can only attend to previous words and not future words, allowing the model to generate coherent sequences. The original transformer architecture had both an encoder and a decoder. The encoder used self-attention to capture context, while the decoder used masked self-attention to generate output. These two components were connected, enabling the calculation of encoder-decoder attention tensors. The encoder produced key and value representations, which the decoder then used along with its query to calculate attention and generate output. The first transformer was particularly designed for to sequence tasks such as language translation. For instance, if a sentence in English needed to be translated into French, the encoder would first process the English sentence. It calculated self-attention, producing query, key, and value representations to capture word similarities and context. These outputs were then passed to the decoder. The decoder used this information to generate the translated sentence in French by computing its own queries, keys, and values while attending to the encoder outputs. For example, if the input was "pizza is great," the encoder would calculate the attention scores and pass the resulting context-aware representations to the decoder. The decoder would then generate the translated sentence, word by word, using masked self-attention to ensure proper sequence generation. This combination of encoder and decoder, connected through attention mechanisms, is the foundation of the first transformer. It enabled sequence-to-sequence modeling, particularly effective for language translation, converting English into French, Spanish, or other languages. In summary, the encoder captures context using self-attention, the decoder generates sequences using masked self-attention, and the two work together through encoder-decoder attention. In the next lecture, we will explore more details about encoder-decoder transformers. I hope this explanation is clear so far.